Okay, students, in this lesson we are looking at proving lines are parallel. In our prior lesson, we looked at when two lines are parallel. So if two lines are parallel and they are cut by a transversal, so these two lines are parallel, cut by a transversal, then we have 8 unique angles. And all of these angles have a special relationship. So if I call this angle angle 1, angle 2, angle 3, angle 4, 5, 6, 7, 8. When those two lines are parallel, and I'm just going to call these lines line L and line M. When those two lines are parallel, those angles have a special relation. So for example, angle 1 is congruent to angle 5 because they are corresponding angles. I can say that angle 1 and angle 7 are also congruent because they are alternate interior angles. Angle 2 is congruent to angle 8 because they are alternate interior angles. And angle 2 plus angle 5 add up to 180 degrees. They are supplementary. You can say the same thing about 4 and 8. Alright, today we are looking at the converse of these 4 theorems. So we're looking at the converse. We're working backwards. So let me show you what I mean by that. I'm just going to erase all this. Let's erase all this. And let me show you what I mean. So let's say that I have two lines, and let's call these lines, again, let's call them L and M, L and M. And let's say we have a line that is a transversal, it's cutting them, all right? So that's all I know. I don't know whether line L is parallel to line M. But what if I said that this angle here is congruent to this angle here? Well, those two angles are congruent. That would mean that line L is parallel to line M. We call this the converse of the corresponding angles theorem. Alright, so because we know that those two angles here are congruent, we can say that, oh, L and M must be parallel. And so we're looking at the converse, and that's what that theorem is called. In fact, I'm going to write down the actual definition for you guys to have. So here's the actual definition. If two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. And that's exactly what we looked at right now. So the same can be said about the other 3 theorems. I'm going to erase this now. Let's erase this. And I'm just going to move this up a little bit. Up here. So, well, we have the alternate interior angles, so we can also say that the converse of that theorem is also true. So let me write that down for you guys here. So here we go. The converse of the alternate interior angles theorem states if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So once again, if I have two lines and I have a transversal and I know that the angles inside the alternate interior angles are the same, then we can say that those two green lines are parallel. Now, again, we can apply this to the other theorems. and we have the converse of the alternate exterior angles theorem. And so what this says is if two angles are alternate exterior angles and congruent, then we can say that those green lines are parallel. Now we have the consecutive interior angles theorem, or the same side interior angles theorem. And that one states that if two angles are on the same side and they are supplementary, meaning they both add up to 180 degrees, then we can say that those angles are supplementary. And the two lines add up to 100, well, the two lines are parallel. So for example, if I have this angle here and this angle here are supplementary, meaning they both add up to 180 degrees, then we can say these two green lines are parallel. Okay, so hopefully that makes sense. Two of the things I want to go over with you guys is what we call the converse of the perpendicular transversal. I know that sounds hard, but it's very simple. This one here states that if you have two lines that are perpendicular to the same line, so these two lines are perpendicular to the same one, so these two lines are both perpendicular to this right here, to this line and this line. If that's the case, then we can say these two lines must be perpendicular, and we call this the converse of the perpendicular transversal. Okay guys, we have one last one. The last one says that we call this the parallel postulate, and basically what this says is this. If I have, let's say I have a line, let's call this line L, and I have a point not on line L, so a point here. How many lines can I make that would go through this point? Let's call this point P. How many lines can I make that go through that point P that are parallel to L? And the answer is, well, just one. I can only draw one line that's parallel to line L that passes through point P. We call this the parallel postulate or the parallel axiom. And that's it. It's a very condensed lesson. Hopefully it makes sense. Please let me know if you have any questions.